Good day, welcome back. In this video, we are going to solve a DC shunt generator for problem number 5, where a shunt generator supplies a full load current of 100 amperes at 110 volts. The shunt field resistance is 55 ohms and stray losses are 500 watts. If the machine efficiency at full load is 86%, calculate the armature resistance. First, we have to write the given. Full load current of 100 amperes IL at 110 volts. The VL, or the load voltage, or the terminal voltage. The shunt field resistance is 55 ohms, so 55 ohms as the RSH. Stray losses, or the P stray, is equal to 500 watts. The P stray, later we will draw the power flow diagram. And also the machine efficiency at full load is equal to 86%. Now what is required in this problem is the armature resistance. Okay, let's write what is the required. We have armature resistance is RA. Then we are going to find the RA, but first we have to find the ISH, the IA, the PA, or the power developed in the armature. First thing to do is to draw the shunt generator circuit and also the power flow diagram. We have here the shunt generator. Okay, we have here the shunt generator circuit. And the power flow diagram, where the shunt generator circuit RSH as in the equation we are going to find the RA, where the output current is 100 ampere. We are going to find the IA is equal to ISH plus IL from this node here. So IL is equal to 100 ampere, which is given. ISH is equal to VIR, V over R, which is the voltage of 110 volts, over RSH, which is 55 ohms. 55 ohms. Therefore, IA is equal to 110 volts over 55 ohms plus 100 amperes. IA is equal to 110 divided by 55 is 2. 2 plus 100, you have 102 amperes. Now that we have IA, we are going to find EG. Step 1. At EG is equal to VL plus IA RA. So in this equation, we have VL, we have IA. To get the RA, we must have the EG. So in what way we can get the EG? Okay, let's try this power flow diagram. So the power flow diagram, input is the mechanical input or the overall input of the generator, and P out is the overall output of the generator. Since given of efficiency of 86%, 86% efficiency, and the formula of efficiency is equal to P output over P input, we can now get the P input. Then we have P input is equal to P output over efficiency. P output is only VLIL from this formula. VLIL over the efficiency of 85%, 86% rather, from the given. So we have 110 volts times IL of 100 amperes, efficiency of 86%. So we have 110 volts times 100 amperes over 0.86 is equal to 12,790. 12,790.698 watts. That is the overall input. Okay. From the power flow diagram, the overall input, which is 12,790 watts, is right here. Okay, while the EG, which is the one we are going to find, is right in the power developed in the armature. To get the power developed in the armature, or the PA, we are going to subtract the power loss of the copper, or the stray losses of the copper. So P in, power input, minus power loss or core loss is equal to PA, or the power delivered, power developed in armature. So we have step 2. Power developed, or PA, is equal to P in minus P losses, the stray losses. So we have 12,790.698 minus 500 watts of stray losses. So we have 12,290.7 watts as the PA. Now that we have the PA, the formula of PA is, using EG, PA is equal to EGIA. We already have the PA and the IA. Then we can now get the EG. EG of PA over IA. Therefore, PA of 12,290.7 divided by IA of 102 amps. We have 120.49 120.497 volts. Then to get the RA, step 4, from that formula, EG is equal to VL plus IARA. We already have EG, VL, and IA. What's missing is the RA. Therefore, EG of 120.497 is equal to VL of 110 volts IA of IA of 102 times RA, which is missing. Then let's rearrange the equation. RA is equal to 120.497 minus 110 divided by 102. RA is equal to 120.497 minus 110 divided by 102. We have 0.1029 ohms. That's the final answer. Therefore, RA is equal to 0.1029 ohms. That's all, and thank you. Okay, here is the another problem of a DC shunt generator where the output of a shunt generator is 66 amperes. We use green. 66 amperes and 100 volts. So this is an output. Let's write the given. An output of 66 amperes. So 66 ampere is IL, or the output current, the load current, and a voltage or a terminal voltage or load voltage of 100 volts VL. The armature and field resistances are respectively 0.04, so 0.04 ohms as the RA and 25 ohms as the RSH. If the efficiency of this load is 88%, so efficiency of 88%, required is the, what is the stray loss? Determine the core and friction. Core and friction losses are the stray losses. Okay, remember from the power flow diagram where the stray loss is equal to iron plus friction loss, and it is located before the power developed in the armature. This is the mechanical loss. Okay, let's start with drawing the circuit and the power flow diagram. This is the shunt generator circuit and the power flow diagram. What is missing, or what is the required? The stray loss. Okay, the stray loss is located here before the power develop and after the input power, or the overall input, the mechanical input. So in this circuit, RSH is given and RA. So the basic, oh no, step 1, the very first thing to get here is the ISH. Why? Because RSH is given and the terminal, or the VL, is already given. So from the formula, we have VL over RSH. Why we use VL? Because they are parallel. They have the same voltage. The VL and the voltage, shunt voltage, is the same. Therefore 100 over, from the given 100 volts divided by 25 ohms, we have ISH of 4 amperes. Then from this point, we can now use a nodal analysis. Or the KCL. We have IA is equal to ISH plus IL. It must be 4 ampere plus IL of 66 amps. We have IA of 70 amperes. Okay, that's the basic thing to do, where IL is already given and the VL. Then next, we have to find the armature loss. With this, we can now find the armature loss. Actually, there are many approaches to this problem. What we are going to do is to find the armature loss here. From the output, we have to find the armature loss, or the copper losses, plus the stray loss. copper losses plus the output, then the input minus the output and the copper losses, we can get the stray loss or the PC o core loss. So the armature loss from the formula, we have PA loss IA squared RA. So we can have 70 ampere squared times RA of 0.04 ohms. So we have 196 watts. Also the field loss or the shunt loss, we have PF. We have the armature loss and the field loss or the shunt field loss, which is the shunt and the armature. This is not a series generator, so there is no series power loss. Therefore, shunt and the armature power is the RD copper losses. So we have total copper loss or PCU is equal to armature loss of 196 plus the shunt field loss of 400 watts. So the total copper loss is 596 watts. Then we have the output of PO of VLIL, which is 100 times 66 amps or 66 amps. Now we have 6,600 watts. With the given efficiency, we have P input is equal to P output over efficiency. So we have while P input is equal to P out plus total losses. Therefore, losses is equal to P out put over efficiency, P output over efficiency minus P output. Therefore, losses or total losses is equal to 6,600 watts divided by 0.88, the efficiency, minus 6,600. Minus 6,600, 900. Total losses is 900 watts. Now, the 900 watts is the total loss. Total loss total loss P loss total is the core loss and the copper loss. Now we have the power total loss and we have the copper loss. We have the total power loss and the copper loss. We can now get the core loss. Therefore, core loss or the core loss or the stray losses or the core and the friction, iron and the friction which is required, we can now have P total loss. We have 900 watts minus the total loss of the copper, 596 watts. So we have 304 watts, the PCO or the stray losses. Stray losses, that is the iron and friction loss. Therefore, the answer is equal to 304 watts. 304 watts. That's all. Thank you.